on here. There is no official new material this week. There are a couple of things I wanted to show you. The first one I think is something that's going to change your whole perspective on linear programming. I held off for a week just because the department asked us to make sure you guys work through it on your own first. But this first tool I think is just an amazing tool when it comes to linear programming as far as a work saver. It's a little bit tricky to program, but we'll look at some of the options there. So I'm going to share my screen here, and I'm going to bring up Microsoft Excel here. And this is actually one of the questions from the homework. Oz Company makes lion food out of giraffe and gazelle meat. Giraffe meat is 18 grams protein and 36 grams fat. Gazelle meat is 36 grams protein and 18 grams fat per pound, obviously, is what we're talking here. A batch of lion food must contain at least 25,200 grams protein and 37,800 grams of fat. Now, these numbers might be slightly different than the ones you had when you did this problem in the homework. That's because this is an algorithmic question, so the computer does change the numbers for each person. So if we have let's minimize the cost of a batch. If giraffe meat is $2 per pound and gazelle meat is $4 per pound. So we have an objective function here, which is going to be to minimize cost of 2x plus 4y, where x equals pounds of giraffe meat and y equals our pounds of gazelle meat. Now our constraints, subject to, well, one of our constraints is we had to have at least 25,200 pounds of protein. So giraffe meat has 18 grams of protein, so that's 18 times x, plus gazelle meat has 36 grams per pound, so that's 36y, and that has to be greater than or equal to 25,200. That's our first constraint. Now I'm going to actually slide that over here. That's our constraint for protein. We have a constraint for fat, which is saying we need 36 grams of fat per pound for the giraffe, plus 18 grams of fat per pound for the gazelle, and we need at least 37,800 pounds or grams of fat in our batch for the lion food. So these are our constraints. Of course, we also have the trivial constraints. Of course, x is greater than is equal to 0 and y is greater than or equal to 0. But as always, we tend to kind of ignore those because those are just kind of assumed to be true. Well, in Excel, we have a tool called the solver. If you don't have it, if you check in your data tab, and go over here in this analyze section where the data analysis tool pack would be. Many of you added that add-in early in the semester. The solver would be with it. If it's not there, you have to go back and add it as an add-in. So if you do a search for add-ins, and data analysis is one of the standard ones and solver is one of the standard ones. So let's go back here and let's set this problem up. So let's look at giraffe meat, which is our variable x, and gazelle meat, which is our variable y. this is just going to be pounds of each is going to be here. This is basically the value of our variables, X and Y here. We're going to leave those blank. Then we have a constraint for protein. Now, all I'm putting in here are the coefficients. Notice for protein, the coefficient of X is 18, so I put 18 under the giraffe. Coefficient of Y is 36, so I put 36 under the gazelle. This amount here is going to equal this coefficient times whatever value X becomes, plus this coefficient times whatever value Y becomes. Now I'm going to make myself a note here that I want this to be at least 25,200. That's not really part of what Excel needs to know, but it's a note for myself when I go to enter this in the solver, so I don't have to refer back to the original problem to find that information. Now for fat, if you look at the constraint for fat, the coefficient on the X is 36 and on Y is 18. And then the total amount of fat is going to be this coefficient of X times the actual value of X plus the coefficient of Y here times the actual value of Y. And again, both of those here are 0 right now because there are no values in there for X and Y. And I'm going to make a note over here again for myself that the fat here needs to total at least 37,800 pounds. And I'm going to put in my objective function. I'm going to minimize cost. Here's my objective function here. My cost, well, it's the coefficient of X is 2 and the coefficient of Y is 4. So that cost would be this coefficient times the actual value of X plus this coefficient times the actual value of Y. And we are minimizing that. So I'm just going to make a note again here to minimize that. Now, some of you that are good with Excel may have noticed that there were a lot of ways that I could have put in these formulas quicker so I could copy them down instead of entering them for each one. I just entered each one separately because I wanted you to see where they came from. But yes, there are a lot of ways to enter that way faster than I did. Well, right now we have all the information entered in Excel that we need for the solver to work. So I'm going to click on the solver up here and it pops up. First it asks, what is my objective function? So what I need to do, I'll highlight that and then I'll click right here. That's where the value of my objective function is going to show up. And I'm trying to minimize that. So in my second row here, I click minimize. Now, this only has 2 variables in it, but it would work with 3 variables as well. So all the stuff in the simplex method, simplex only works for maximization, standard maximization problems. The solver will work for maximizing or minimizing. So it avoids all those things you have to do in the simplex method to convert a minimization problem into a maximization problem. Now it's asking us what cells are changed. This is basically asking us what cells contain our variables. That's these 2 cells right here. That's X and Y. And then our constraints. We're going to add our constraints. And our constraints, of course, the first constraint is protein, but really it's just this value right here. And we want it to be greater than or equal to. So I change that sign to 25,200 grams. And I'll add that. And then this is my constraint for fat. So I click on that. I want that to also be at least or greater than or equal to 37,800. Now I can either click add, or since it's my last one, I can just click OK. If I click add, then I just have to click cancel here to get back to my main screen. I see my 2 constraints that appear there. Make all other unconstrained variables non-negative. That's my trivial constraints. X is greater than or equal to 0. Y is greater than or equal to 0. This next one here, it usually works out right even if I leave it as GRG. But I want to change it to simplex LP because that's the process we're actually using. And so we want to make sure that we set it so that it'll always give us the same answer as the simplex method. Then we click solve. Now it's going to give us a warning that it's going to change some of our values. And so we're going to click keep the solver solutions, leave that clicked and just hit OK. And it gives us our solver solution here. It is saying that we need Minimum cost is right here, $2,800 when we use 933.33 or 933 and a third pounds of giraffe meat and 233 and a third or 233.33 pounds of gazelle meat. So that is the minimized solution for that problem very quickly. Now, something that comes up on two problems in the homework and in the book is something called shadow costs. Shadow cost is the cost by increasing, or cost of increasing, the required amount of one of the constraints. By one. So here we have two constraints. We have one for protein and one for fat. They'll have a separate shadow cost. So to change or to find the shadow cost, we're going to go back into our solver. And this first constraint is the constraint for protein. So I'm going to edit that. So I'm going to hit change. And what I'm going to do is instead of 25,200 pounds, I'm going to increase it by one. So it's 25,201 pound. And I click OK, and notice it has changed that constraint here. If I click solve now, you can see the amount of giraffe meat and gazelle meat has changed, and my cost has changed. If I increase required protein by 1 gram, the minimum cost increases by 11 cents. Or 1/9 of a dollar. I believe my WebAssign wanted it as 1/9 of a dollar to enter that one. So that is the shadow cost for protein. Well, let's look at for fat. So what we're going to do is we're going to go back to our solver. We're going to change this back to what it was before for protein. So just 25,200. So click OK there. Now we want to increase the required amount of fat by 1. So we're going to change this from 37,800 to 37,801. And we'll click solve. And notice the amounts here changed, but the cost did not. It's back to $2,800. So we can increase required fat by 1 gram, and the price does not change. In other words, the shadow cost for fat is nothing, $0. It doesn't cost us anything to increase the amount of fat by 1 gram. Now, you can see without the aid of technology, finding the shadow cost would require us to resolve this whole linear programming problem. That's not really a practical thing to do. But you can see here right now, it is 6:15. And not only have I solved the problem, I normally, using the simplex method, I would have struggled to solve the problem in 15 minutes. But I actually have the shadow cost for both as well. Now, the next one I want to solve is there is one that is in the homework. It asks you to solve using duality. And I want you to minimize the function c equals 2x plus y plus 2z, subject to the constraints 3x plus 2y plus z is greater than or equal to 100. 2x plus y plus 3z is greater than or equal to 200. And of course, X is greater than or equal to 0. Y is greater than or equal to 0. And Z is greater than or equal to 0 are trivial constraints. Now, this is not only is it a minimization problem, it's a standard minimization problem because it's minimization and all the constraints are greater than or equal to. Remember, a standardized maximization problem, it was maximizing the objective function, all the constraints were less than or equal to. So this one can be solved with duality. We can do the matrix, we can transpose the matrix and whatever, but we don't have to. We don't have to. Let's look at using that solver. So X, Y, and Z. So these are the first row is going to be the values, just the variables X, Y, and Z. So I'm just labeling X, Y, and Z at the top. But my second row is where the actual values for those variables are going to be. For first constraint, it's 3x, 2y, and 1z. So this value here would be this times the value of x plus this times the value of y plus this coefficient times the value of z. And of course, right now that's 0 because these variables are blank. And I want that to be greater than or equal to 100. That's what the first constraint says. The second constraint is 2x, 1y, and 3z. So again, that value is going to be equal to this coefficient of x times the value of x plus this coefficient of y times the value of y plus this coefficient of z times the value of z. Again, that's 0 right now, and I'm going to make my note. I want that to be greater than or equal to 200 for that second constraint. And that's all I really need. I don't need my trivial constraints because that's addressed. My objective function is going to be to minimize 2x plus 1y plus 2z. And again, that value will be this coefficient of x times the value of x plus this coefficient of y times the value of y plus this coefficient of z times the value of z. I'm just going to make a note here. I want to minimize that. Well, we go to our solver. First thing, my objective function. Click on that there. And I'm just going to click on this cell here. That is the actual total value of the objective function. We're going to minimize. So I click minimize by changing what variable. So I click in there to make sure that's flashing. And I'm going to go up here and highlight this 3 cells where I have the values for x, y, and z are going to become. Click on my subject to the constraints and hit add. I want this value, and my note says greater than or equal to 100. I'll add that. And oops, that's the wrong one. This value here is my second constraint. That's supposed to be greater than or equal to 200. So I have my 2 constraints. Unconstrained variables are non-negative. We change this to simplex LP. And we just hit solve. And yes, we want to keep the solver solution. And notice it tells us x equals 0, y equals 20, and z equals 60. So C is minimized at a value of 140. That's from right here. When we use the values 0, 20, 60. X is 0, Y is 20, Z is 60. Again, that took 4 or 5 minutes. To solve that using duality is an ugly problem. It's an ugly process. To be honest, to use duality takes me about 25 or 30 minutes. So I highly encourage you to get used to this solver tool. Just because on the test, if you're using the simplex method, you can't afford to be putting 20 or 30 minutes into a problem. I don't remember how many questions are on the test. They've asked me not to say anyway, but you're looking at 20 to 30 questions on a test. you can't spend more than 5 or 6 minutes per problem on average, or you're going to run out of time with that 3-hour time limit. So this tool here, I highly recommend it. So I'm going to stop sharing here and get back in here. Does anybody have any questions on that solver tool? On the final exam, even if it requests a certain method, that's a great question. All it's really looking for is the solution. So there is no, if it requests a certain method, it's actually trying to use that as a hint to help you solve it so that you can't just graph it or whatever, but you can use whatever method you want to solve them. You're not going to lose any points. You can't show work in an online test anyway, so you won't lose points for doing it a different way. You're welcome. Like I said, realistically, this solver tool is a huge game changer. Now, if you haven't noticed, I did go back in and I opened up the week 11 homework and quiz in WebAssign. I reopened it, so it'll be open until this Saturday, so you can still work on that if you want to. Now that you have this tool available, I did add some time to the quiz for you. If you need more time, let me know. If you do go back in and rework any of the homework or quiz, send me an email letting me know when you're done so I can update your grade in Canvas for you so you can get credit for the additional work you've done. Like I said, the department had asked me not to show you this tool until you've worked on linear programming a little bit by hand. But now that you have this tool, if you didn't get a chance to finish that stuff up, you should be able to go back and redo it rather quickly. And like I said, you're allowed Excel on the test. So please feel free to use this tool to make the test more manageable as well. Anybody have any questions? Okay, well, that's really all I had for you tonight is I wanted to show you those examples and show you that solver tool. So if you don't have any questions, I'll let you guys go. Good luck on the exam.
Yeah, it was a pleasure having you as the professor this semester or whatever, quarter or whatever it is. Thank you for all your help and stuff too.
You're very welcome. You have a great week.
Take care.
Thank you.
Push it back.